Obtain the mesh file and also the full training movie by purchasing this product.
In this project, we will simulate the fluid flow around a wavy tape in a tube. The present study investigates the fluid flow passing through a circular cross-section tube using a wavy tape as a barrier. This waveform acts as a thermal insulator, and the purpose of the present study is to investigate the heat transfer inside the tube. The present 3D model was designed by Design Modeler software. The geometry of the model is a circular cross-section tube having barriers in the form of a wavy bar. Due to the symmetry of the model, the desired geometry is designed as a semi-cylinder. The meshing of the present model is done using ANSYS meshing software, and the mesh type used in this geometry is unstructured. The element number is equal to 653,307. Under the General Setup tab, you can see different buttons from scales to units. Also, by clicking on Report Quality, again in the Console tab, the Fluent software will give you the quality report for your mesh. For example, you can see the maximum aspect ratio of your mesh, maximum orthogonal quality, and etc. After double-clicking on the Energy button in the appeared box, you can see that we have enabled the energy equations since we wanted to calculate the temperature changes and temperature distribution inside our computational domain. Now, if you click on any of those edit buttons for different parameters in the appeared window, you can see that, for example, the density here is defined in the terms of temperature with 3 coefficients. It should also be pointed out that polynomial functions and their coefficients are taken from these equations. Also, if you intend to add another material, all you have to do is to click on Fluent Database and select another material from the available list of materials in the Fluent software. Also, if you click on the Thermal tab, you can see the temperature of the water liquid. Now, by clicking on the outlet boundary, the type of this boundary is defined to be pressure outlet. Again, by clicking on Edit, a new window will appear. In the appeared window, the most important part you should pay attention to is the gauge pressure, which is here defined to be equal to 0, which means that our water liquid will exit our computational domain to the atmosphere. Now, if you click on this wall boundary, under the Momentum tab, you can see that the stationary wall motion along with no slip shear condition are defined for this. And if you click on the Thermal tab for this wall, you can see that the thermal condition of heat flux here is defined. And here you can see that the value of the heat flux applied on this wall is equal to 0, which means that this wall is adiabatic. After double-clicking on the Run Calculations button in the appeared section under the Parameters part, by just defining the number of iterations, and then clicking on Calculate button, the software will start the simulation process. Now in this part, we have extracted 3D and 2D contours by the means of CFD post software. Now in order to extract the streamlines, all you have to do is to click on the Streamlines button and accept the appeared window. After that, just like the previous slides, on the lower left side of the software window, in front of the Start From section, we select the Inlet boundary. After that, we click on Apply and the software will show us the streamlines. Now in this streamline contour, you can easily see the wavy tape has the responsibility of mixing the flow in order to increase the heat transfer rate. Now in this 2D temperature contour, you can easily see that as the water liquid passes through the tube, its temperature increases. Finally, the summary of different settings and setup that we have used in our project is presented to you in the slide.
Obtain the mesh file and also the full training movie by purchasing this product.
To benefit from Mr. CFD services including simulation, consultation, and training, contact our experts via info@mrcfd.com.